Yes. Okay, put your hand down. Bete, we have done few things. Chapter is going applications of derivatives. Almost everything we have completed, but still we may have some doubts. If we are facing some problems or doubts in the chapter, then today I'm ready to discuss on that. Then we need to start the next chapter after this. So let me see if any doubt you are having. If you have some doubt, then you can raise your hand. See, a question comes. This is also one of the very good question. Show that the height of the cylinder of the greatest volume. Show that the height of cylinder of greatest volume. It is miscellaneous exercise question number 18. Show that the height of the cylinder of the greatest volume, which can be inscribed in a right circular cone of height h and semi-vertical angle alpha, is 1/3 that of cone. The greatest volume is 4/27 pi h cube 10 square alpha. So now, see, first of all, we have been given a cone. In this cone, we have to put a cylinder so this is the cylinder. We are going to put different color. I am going to put the cylinder. Semi-vertical angle is given to us as alpha, and one more thing, height. Cone height is given small h. Cone height is given small h. Cone radius we are supposing is small r. Means we have supposed radius as a small r and height as a small h for the cone. And for the cylinder, we are supposing height as capital H now and radius as capital R. We will be able to see a small thing that it forms two similar triangles. Two similar triangles. This angle is alpha. This one triangle, the top one, and the full triangle. These two triangles are similar to each other. So we are going to discuss about the similarity criteria, and with that similarity criteria, just see, this was given small r, this whole is h, capital H, capital R. So this all is with us now. Similarity criteria, perpendicular upon perpendicular, perpendicular of chota triangle will be h minus h on perpendicular of big triangle, that is h, is equals to radius of a small triangle, capital R, radius of big triangle is small r. As small h was given, that's why small h and capital H is coming in a different scenario. This we are going to use. So let us go for the thing now. See, in the question it is said, show that the height of the cylinder of the greatest volume, which can be inscribed in the right circular cone of height h and semi-vertical angle this, is 1/3 that of the cone. The greatest volume means we need to discuss about the volume. So volume of the cylinder is pi r square h. Now we need to convert it into one variable. To convert it into one variable, r value we are going to put. So it will become pi r value from here I am going to put. So it will become h minus h into r upon h to whole square into h. Now see, capital H is variable, small h is constant because cone is given to us. So small h is constant only and only it becomes with one variable, that is capital H. R will also be, small r will also be constant. So V can be said as function of capital H. Now I could write it as H is equals to pi h minus h2 whole square r square h upon h. Further, I could open the bracket, this whole square one bracket I am going to open, so it will be pi r square upon h, because these things are constant, h square plus h square minus 2h into h. This becomes, let us open the bracket, pi r square upon h. H is not that visible. It becomes h square h plus h cube minus 2h h. Now its differentiation we need to do. Fh has come to us. Fh equals to pi r square upon h square capital H plus h cube minus 2h square. So this we are taking to the next slide. Fh was equals to pi r square upon h square h plus h cube minus 3h square. Now we need to calculate f dash h. So it will be pi r square upon h square into h differentiation will be 1 plus 3h square minus 6h. Up to this, I don't think there is any problem. Or better will be one more step I am taking that will make you more easy. I suppose this step will take us to little easy steps. I'm going with this. This will make us little easy. Fh will be equals to pi h minus h2 whole square r square h upon h. This we are taking to the next slide. This will take us little faster, I suppose. So fh is equals to pi r square upon h minus h2 whole square into h. F dash h will be pi r square upon h. First function h minus h2 whole square into differentiation h will be 1 plus h. Its differentiation will be 2 h minus capital H into 0 minus 1. So it becomes pi r square upon h minus h2 whole square minus 1 will make it negative 2h minus h. Now we need to put f dash h equals to 0. This becomes h minus h2 whole square is equals to 2h minus h. Up to this, I don't think there is any problem. Now see, h minus h2, 1 power will get cancelled. H minus h is equals to 2h. H is equals to 3h. So they are saying us that height of cylinder is 1/3 that of height of cone. This only is to be proved. Height of the cylinder is 1/3 that height of the cone. This was the first part of the question. Now we are going to the second part. In that it was asked to us what will be the maximum volume. So volume was, hope you remember, volume FH. We have calculated, I kept it in the box, pi h minus capital H2 whole square r square h upon h. In this we are going to put the value. So FH, that is volume, equals to pi h minus h2 whole square r square h upon h. Now just now we have calculated the value of capital H, that is 1/3 of small h. Capital H is 1/3 of small h. Capital H is 1/3 of small h. Let us put in place of capital H, pi h minus h by 3 to whole square r square h upon 3 whole upon h. So now we need to only simplify this. After simplification, we will be able to get the value. And then also one thing more is left with us. So first of all, this much we are going to do pi. It becomes LCM 3h minus h to whole square r square upon 3. It becomes pi by 3. This will become 2h by 3 to whole square r square. I could write it 4h square r square upon 27. Now, one small step also I need to take, that is from the first slide, I need to find the value of tan alpha because tan alpha is required. So over here, I'm showing you tan alpha will be equals to R upon H. I suppose at this step, there is no such doubt. Wait, Krishna, 1 minute, wait. Yes, Krishna.
सर ये जो FH वाला स्टेप है इसमें डिनोमिनेटर में h स्क्वायर नहीं होगा?
Yes, you are right. Remove your raising hands. Fine. So it becomes now, there is a small change. Now, just now we have calculated R is equals to H tan alpha. So it becomes 4 by 27 pi H. R square can be written as H tan alpha to whole square. So what it becomes, I'm writing with different color over here. It is 4 by 27 pi H into H square, H cube, tan square alpha. Hence proved. This only was the target to prove. Now we need to calculate H dash alpha. See, we have calculated F dash H. It's over here. I must copy it, pi R square upon H square. This H square has not made any problem, but yes, it was wrong. H minus H2 whole square minus 2H, H minus H. So we have got F dash H is equals to pi R square upon H square H minus H2 whole square minus 2H H minus H. F double dash H equals to pi R square upon H square. Now it becomes 2H minus H. Then it becomes 0 minus 1 minus 2H it becomes 0 minus 1 minus 2H will become 1. It becomes H minus H. Now opening this bracket, this must come greatest mean negative. So pi R square upon H square. I'm opening this is already negative 2 H minus H minus minus plus 2H minus 2H plus 2H. This will get cancelled. Now see overall negative sign we can take common. It becomes minus pi R square upon H square 2 h minus h plus 2h. So we are able to see overall is negative. So maximum. Volume will be maximum. Volume will be maximum when height of the cone is equals to height of the cylinder is 1/3 the height of the cone. This is one of the very good question. If it comes in the board examination, it comes for 6 marks. So please take care of this question also. You are able to see whichever questions are coming for 6 marks, that questions in the case of slide system, I am able to do them on the 4 slides. But these 4 slides, when you are doing in your copy, it takes hardly 1 or sometimes 1.5. But these questions are really very important. Video of this, all the things I'll send you today itself. So please take care of this. It's one of the very good questions and it is asked also. Question number 12 of the miscellaneous exercise. This also I'm going to discuss. See this question. A point on the hypotenuse, a point on the hypotenuse of a triangle is at a distance AB from the sides of the triangle. From the sides of the triangle, this I'm taking A, this I'm taking B. First x-axis one we need to take, so A, B. This indicates this distance is A, this distance is B, perpendicular distances I could say. Show that the minimum length of the hypotenuse, we need to show something. So if this angle is theta, this is for sure, this will also be theta. Now, I'm saying it as P and this as Q. P upon A, that is hypotenuse on base. Hypotenuse on base is sec theta. So P is equals to A sec theta. Likewise, Q upon B will be equals to hypo on perpendicular, that is cos sec theta. So Q will be equals to B cos sec theta. So the length of hypotenuse will be P plus Q. This becomes function of theta. What it will become? P is A sec theta plus B cos sec theta. Now I suppose you are able to calculate F dash theta. Then we'll put it equals to 0, then F double dash theta. This you need to try. It's a very good question, important also, but you have to try this. It's really a wonderful question. Please do it. If you will be getting doubts, then we'll discuss in the next coming class. Take care of this question. This is really important. One more important question I'm going to discuss after this. This one is question number 11. A window is in the form of a rectangle surmounted by semicircular opening. See, a window is in the form of rectangle surmounted by a semicircular opening. On this, a semicircular opening is there. If somebody has visited my home, then in my home, a window is like this. A window is in the form of a rectangle surmounted by a semicircular opening. The total perimeter of the window is 10 meters. Total perimeter, I'm saying it as X and this as Y. So perimeter equals to 10. Perimeter will be Y plus X plus Y plus this will be x by 2. So its circumference will be, circumference of the circle is 2 pi r. It is half circle. So it will be pi r. R is x by 2 is equals to 10. Now, first part is over. A window is in the form of a rectangle surmounted by a semicircular opening. The total perimeter of the window is 10 meter. So this much is over. 10 meter is the perimeter. Now next part is coming. Next part is saying us that find the dimensions of the window to admit the maximum light, means area. Area will be length into width, means x into y, plus area of the semicircular opening, that will be half of pi r square. R is x by 2 to whole square. Now we need to convert it into one variable. So from this part, I'm going to put the value of y into the another. So value of y we are going to calculate in this. So it will be 2y plus x, 1 plus x by, 1 plus pi by 2 equals to 10. So 2y will be equals to 10 minus x, 1 plus pi by 2. Y will be equals to half of this 5 minus x by 2, 1 plus pi by 2. The value of y we will put over here, x, 5 minus x by 2, 1 plus pi by 2, plus 1 by 2 pi x square upon 4. This becomes function of x. After making it function of x, now we need to solve it. One more simplification I'm doing. 5x minus x square by 2 minus pi x square by 4 plus 1 upon 8 pi x square. This is function of x. We can simplify these two steps also. And then we need to solve this question. This is also one of the very great question. Similar to this, one more question has come in the board examination, that also I'll tell you. First of all, see this once. So this one is over. Now, similar to this question, which has come in the board examination, I'm going to tell you that. So that question was, which has come in the board examination. This was a window is rectangular at the base and equilateral triangle on the top. Equilateral triangle on the top. To admit maximum light from it, what should be the dimensions of the window? It is given us that the perimeter of the window is 10 meters. Note down this question. Please write it. A window is rectangular surmounted by a equilateral triangle. If its perimeter is 10 meters, then find the maximum area to allow maximum light through the whole opening. So this is one of the questions which has come in the year 2013 board examination. This question has come. Exactly, NCERT questions are important, and if some questions are given in NCERT exemplar which are similar to NCERT book, that are asked more in the board examination. So this is one of the question which is similar to the NCERT book, but a small difference they have made. It is important for the board point of view. Vikas, you can stop recording.